Okay, Assalamualaikum and good morning to everyone. Okay, my name is Sitila Hafiza binti Muhammad Khazai from UiTM Pahang, Faculty Applied Sciences. Okay, for today, I will continue my lecture on CHM676 Organometallic Chemistry. Okay, for today I'm going to covering for chapter 5 summation of organometallic compound, which we have 4 reaction that we will discuss throughout this chapter. Okay, as you can see, the material are prepared by the LIC of the organometallic chemistry CHM676, Dr. Shahidatul Akmal binti Muhammad Suhaimi, and I'm going to present it for my class. Okay, so for today we will going to discuss about summation of organometallic compound. Okay, as you know, organometallic compound undergo a rich variety of reaction, okay, which may involve in loss or gain of ligand, okay, molecular rearrangement, formation or breaking compounds of bone to the metal and also to the ligand itself. Okay, so the first reaction in um, organometallic compound is substitution reaction in carbonyl complexes. Okay, a typical substitution reaction can be represented by the general equation below. Okay, as you can see from the reaction, okay, we have a new ligand. Okay, after get through the substitution reaction, they will form a new ligand. Okay, this reaction represent an important way to introduce new ligand into complexes. Okay, this type of reaction does not involve any change in the formal oxidation state of the center metal. Okay, for substitution reaction involve in a kinetic study of such reaction indicate that the substitution reaction may have either associative or dissociative mechanism. Okay, so first of all, we can see for example for an associative mechanism. Okay, as you can see from this reaction, okay, the rate determining step, okay, where I have highlight, okay, the slow step involve a bimolecular reaction of hexacarbonide metal and the ligand. Okay, at the first step they have two reactants, okay, so involve to form an intermediate. Okay, so that's why we classify as a one, two reactant to one product at the slow step. Okay, so usually at the slow step is the rate determining step of the reaction. Okay, so the intermediate then lost carbonyl in a fast reaction. So two reactant to one product. This is for associative mechanism. Okay, and for the dissociative mechanism, okay, the rate determining step involve the splitting of one reactant to form two product. So at the first one reactant, we have tetracarbonyl nickel and split into two product, which is have one carbonyl and also this one is a tricarbonyl nickel at the slow step reaction. Okay, then after that the product react with the substitute ligand in the fast reaction. So after split, meaning that they have lost one CO, okay, one carbonyl, and introduce the new ligand to the new product. So after that we can get the new product with new ligand. So meaning for associative mechanism, at the first, for the slow step, we have two reactant and it produce one product which is that is intermediate. Okay, and for the dissociative mechanism, at the slow step or the rate determining step, okay, they have to split. Okay, have to split from one product to form two products. So after that, um, followed by introduced to the new ligand to produce the new compound. This is differentiate between associative and dissociative mechanism in substitution reaction. Okay, most substitution reaction favor to have dissociative mechanism, but there is possible for associative mechanism if they have complexes which have large metal, okay, which is can provide fiber site for incoming ligand to attack, or also if the compound have the highly nucleophilic ligand. So there is possibility for associative mechanism can be occur. Okay, so now we move to the second reaction is insection reaction. Okay, many reaction in organometallic chemistry involve insection of small molecule represent as a XY. Okay, but into metal ligand bond, especially metal carbon and metal hydride bond. Okay, although some of these reactions are believed to occur by direct simple step insection. Okay, so many mass reactions are much more complicated and do not involve a direct insection step. Although at the first, from the observation we can see the insection reaction maybe can be believed to be a direct insection, but actually when we get through the experiment, uh, the reaction is more complicated and do not involve a direct insertion step at all. Okay, for insertion reaction, they have two type of insertion reaction. One is 1,1 insertion. The second one is 1,2 insertion. Okay, for 1,1 insertion, also recognized as Archimedes migration reaction. Okay, on the insert molecule, and insert bond occur only on one atom as shown below. Okay, so this one we have a compound. Okay, we at the first before insertion they have 5 carbonyl and they add with the CO. Okay, in 1,1 insertion. For the methyl group also have the methyl group, and as we can see from the reaction, it seems like a direct insertion. Okay, for the CO, so CO located between manganese and insert between manganese and methyl group. Okay, this one is for 1,1 insertion, also known as alkene migration. And the second insertion is 1,2 insertion. Okay, on the insert molecule, the insertion bond occur on two different atoms adjacent to each other. Okay, so this one they have one carbon, so this one they have two different atoms adjacent to each other. Okay, this one we call it as a 1,2 insertion. Okay, so for the new ligand, just attach directly to the carbonyl group, cobalt group. Replace the H to the another end of the carbon. Okay, so okay, we will look at how small molecules such as carbonyl insert into metal to carbon bond in organometallic compound. Okay, so as you can see from this reaction, it seems like just direct insertion from our new ligand to the central metal. Okay, now we see for the CO in section. As I mentioned earlier, from the reaction, we can see that it seems like a direct attachment between our ligand to the central metal. Okay, for CO in section, also known as carbonylation. Okay, it was found that when carbonyl react with organometal, so the product was this one. As you can see, between our methyl and metal, central metal, um, they have a new CO, okay, or carbonyl. Okay, it seems that CO has insert itself between our metal and CH3, manganese and CH3 bond to produce an RC complex. However, further investigation, okay, when get through the experiment, they label the CO carbonyl with 13. Okay, carbonyl 13 was used. The product was found to be CO carbonyl, carbonyl that have a label not attached between our manganese with CH3, but for this one, mean that directly attached to the our central metal. Okay, so actually at the first thing, the first our hypothesis that the new ligand will attach to the CH3 and the central metal, but through the experimental, the result is again our hypothesis. Okay, throughout the investigation, through the experiment, we conclude that the insert CO is one previously coordinated to the metal, not the label one added to the complex. Therefore, the carbonyl that become the acyl carbonyl is not derived from the external carbonyl, but it's one already coordinated to the metal atom. Okay, meaning that carbonyl that attach between metal to methyl group is come from carbonyl already coordinated to this one punya central metal. Okay, so the incoming CO is added cis to the acid group as shown below. So this one is ligand or CO that come that one that the CO the label CO. Okay, so this one, so CO that attached between, insert between manganese and methyl actually come from already bonded to our central metal. Okay, so any other Lewis bases L can bring along about CO in section as shown in the mechanism below. Therefore, the conversion of alkyl into acyl can be effected by addition of ligand, addition of another ligand, okay, such as of triphenyl phosphate or any Lewis bases. Okay,